Surely there is more than one way to go about this problem. Even though we could go ahead and make a substitution of this 1/3 pi into the numerator and denominator, I'd like to enjoy the memory of those identities from trigonometry. One of our old identities is that the cosecant of any angle is the same as 1 divided by the sine of that angle. Another one of our old identities is that 1 plus the tangent squared of any angle is the same as the secant squared of that angle. I'm going to make some substitutions. After we do make those substitutions, we're looking at the limit as x approaches 1/3 of a pi. That's 2 times 1 divided by the sine x times the sine x all over secant squared of that same angle. We know that cosecant and sine are reciprocals of one another, two numbers whose product is 1. We know that 1 plus the tangent squared is the same as the secant squared. Let's see what remains. That is the limit as x approaches 1/3 of a pi of 2 divided by the secant squared x. Okay, well, I don't have any more simplifying to do. Let me go ahead and make that substitution. That's 2 divided by the secant squared of 1/3 of a pi. Say it again. That's 2 divided by the secant squared of 1/3 of a pi. Well, what is the secant of 1/3 of a pi? That's the same as the reciprocal of cosine of 1/3 of a pi. Cosine of 1/3 pi is that x value on the unit circle. It is 1/2. And if cosine of 1/3 pi is 1/2, that means that the secant is 2. But it's not just the secant. We're talking the secant squared. So that's 2 squared. We end up with 2 divided by 4. Of course, we could reduce that. 2/4 is the same as 1/2. It's not the outcome I was hoping for. I was hoping for 2 over 2. Call it 1. 2 halves of the same whole for Happy Valentine's, but we know this is really just Singles Awareness Day approaching.